Apparently, I'm starting with this slide. So if you have a phone that can do QR codes, you can take a picture of that and get started on the evaluation before you've heard me speak, which I'm OK with, but you may want to wait and see if I actually say anything you like. But before I get started, who here has been working in the software industry for 5 years? Most people, that's what I thought. 10 years? 15? 20? Or still going? 25? I feel like I'm winning an auction here. 30? 30? 30 years. Big hand for the 30 years people. Now, you don't have to have been doing this for 30 years. You don't have to have been doing it for 10 years to know that your world has changed. The software that we're building is not the same software we used to be building. The customers we're building it for are not the same people. The user interface models are not the same. The places we're putting the code, where we're deploying to, are not the same. The business models are not the same. Everything has changed. And hopefully your tools have been changing as well, because those tools that you were using 5, 10, 30 years ago are not going to be working as well for the new models that we're dealing with. Also in this time, and now we're only looking back less than 5 years, Microsoft has changed too. This is a theme that you've been hearing throughout Build, and you'll keep hearing the rest of the time. We're doing things differently now. We're more open. We're less secretive. We're contributing more to open source products. We're more permissive with the licensing. We're more open to other platforms and other operating systems. Just a couple of weeks ago, I was at PyCon, big Python conference being held in Montreal, 3,000 developers, not a huge amount of Microsoft fans there. And one of the really common things that I kept hearing over and over again, people coming up to me, people coming up to our booth during the conference, I love the new Microsoft. I don't use Windows, but I love what you guys are doing. I don't use Visual Studio, but I love it. A whole lot of people who have been noticing the changes that we've been making and the differences and the effects that is having on the software industry. We've changed in this time. We're actually getting things right. But what does this mean for you? It means you're going to get better open source software. Microsoft has been contributing to tools like Git, to tools like Python, Node.js, PHP, to make these run better on Windows. So if you're working on Windows, you have access to better open source software. You're getting better platforms. We're making contributions to Linux. We're making improvements to Hyper-V and to our infrastructure so that these open source platforms will run better for you so you can have just as good access to them as you would anywhere else. And you're getting better open source tools. The tools that we are building are being developed under different models in a lot of cases, which means there's more people involved. Users are directly involved in making these tools better in a way that they didn't used to be, and so they are better tools. Your world has changed, but we're coming with you. Now, this isn't a keynote, so let's get back down to earth. This session, I'm going to be talking about Python. I'm going to be talking about Node.js, and specifically how we support those in Visual Studio, and also how we support them in Azure. I'm going to spend the next 20 minutes or so talking, and then I'm going to hop into Visual Studio, and everything else is code and demos. So if you have questions come up, let's hold them until the end of the talking bit, just in case I get to them. And then from then on, we'll be sitting at the demo machine and seeing some cool stuff. So what's Node.js, and why do we care about it? Node.js is relatively young language. Programming environment is probably a better term. Came about 2009, 2010, was starting to come out. It's JavaScript on the server. It's JavaScript running on top of a really good JavaScript engine, the V8 engine that came out of Chrome, which at the time was the best, it was the fastest, ported to run on the server and to do server-side apps. So it's a young language, but it has all the heritage of JavaScript, and it also has all the future of JavaScript. ES6 comes along, ES7 comes along. Those are getting rolled back into Node. What this means is that you have an experienced pool of developers who have been doing front-end development, they've been doing websites for a long time, who can now extend their scope. They're not just front-end developers, they're full-stack developers, because all the JavaScript they can already do, they can now do on the server as well. And the cool thing about Node.js, and this could only happen in a young language, is it's thoroughly asynchronous. From the start, they said nothing is going to block. No operation at all is going to stop the program from making progress. If you're familiar with C#, you'll know async await, which has come in fairly recently. Node.js had it from the beginning, so everything has it. Everything is thoroughly asynchronous, which makes it great at handling huge quantities of parallel requests, parallel operations, with far fewer resources than other languages are going to require. What about Python? Python's an old language. It's getting on 25 years or so now. It's older than C#, it's older than Java. But it still has a very active development team. The language is constantly being improved, constantly being worked on, and it's in a constant race with JavaScript and C# to see who can add the best new features first. And for a long time, Python's been winning that race. It's a very popular language for teaching. It's very easy to read, but it has all of the core concepts that are important for teaching students how to program. It has a full type system, even though its dynamic typing means you don't spend all your time writing out type names. And it has a huge ecosystem of libraries and support. Basically, every cloud provider out there has Python as one of their top-tier languages for managing and controlling and deploying to their cloud systems. And some of the libraries for Python are so big they have their own conferences. Libraries like Django, libraries like SciPy have dedicated conferences with attendance in the hundreds to thousands. These are not just little meetups. And Microsoft has support for both of these languages. Now, I'm going to hold up for a second here. This is not a product announcement. We've been doing this for years. This isn't we've just decided we're going to start throwing these out there and let you start using Python and Node.js. Python's had Visual Studio support to some extent since 2010. That's 5 years that we've been shipping Python extension for Visual Studio to give you all of the support that I'm going to show you a bit later on. Node.js has been available on Azure since 2011. Even I was shocked by that when I went back to figure out when it first showed up. That's 4 years we've had Node.js support on Azure. This is not something new. This is a serious commitment. Python and Node.js are not disappearing from the things that we're doing. And they're not brand new ideas that we're just throwing out there to see whether they stick. We're committed to Python and Node.js in our tooling and for our developers. And that's why when I bring up a checklist of the features that we support for these in Visual Studio, it's fairly complete. All the features you'd expect to find in Visual Studio for any other language, if you imagine a world where you installed Visual Studio and it just had Python there, it just had Node.js there, you would just expect all these features to be there. And they are. We haven't left things out simply because they're different languages. We've gone through and filled in all the gaps as best we can so that Python or Node.js will give you great editing, great code completion, great debugging experiences. And both of our extensions are recognized as having the best debugging experiences out there for these two languages. Profiling is there. All of version control support of Visual Studio is available. Remote debugging is a great feature that we've made available, and that remote debugging, incidentally, is cross-platform remote debugging as well, because Python and Node.js are inherently cross-platform languages. If you're running that code on Linux, if you're running it on a Mac, you can remotely debug it from Visual Studio. I'll show you that later on. And because they're so heavily supported by packages and libraries, we have package management built in. And this was being developed ahead of and in sync with some of the newer package management stuff that's in Visual Studio. Some of it looks a bit different, but it is effectively coming to the same point, and we are hoping to link in closer with the general Visual Studio support for packages soon. We come to Azure, and again, the picture's fairly complete. This is not something we've just spun up. We've been working on this for a while. All the web apps will support Python and Node.js and have done for years. Cloud service will, of course, let you do that. Linux and Windows VMs, which are available on Azure, you can do whatever you want, and that includes Python and Node.js. The storage services, most of the platform services, in fact. Application Insights has a really great SDK for both languages. DocumentDB supports both languages. These are services that you can use today from Python or Node.js and not feel like you're a second-class citizen. This is true, proper, like first-class support for these languages. And machine learning, which is one of our newest services, is only recently fully released, has Python support built into it. And in fact, the only other language built into Azure Machine Learning right now is R. R and Python, both open source languages. You can't do .NET in that yet. That's really rare for us. We're changing. But here's the question I expect you're asking. Why would I use Python? Or why would I use Node.js? When should I use that? And it's true. There's nothing that you can do in these languages that can't be done in any of the other languages that you may be using. Especially if that other language is C# or .NET in general. Everything you can do in Node.js and Python, you can do in .NET. But for some applications, it's going to be easier. It's going to be smoother. It's going to be faster. It's going to be more enjoyable to use a language that's a better fit for the task at hand. Python is very good at dealing with glue code. This is code that doesn't do a huge amount of processing itself, but it's going to call out to other libraries. It's calling out to other programs and telling them what to do. Python's often criticized for being slow. And depending on which implementation, which version of Python you get, yeah, it can run slow if you're doing intense processing. But if you get a library that can do really fast processing, you can use Python to tell that library to do the processing for you, and suddenly that's not a bottleneck anymore. Most cloud providers have their management services exposed through Python SDKs. If you're on Azure, if you're on AWS, if you're on choose your own provider, they will have a Python library for managing their systems, spinning up VMs, cloning images. I'll show you some of that a little later on. It's highly portable. If you ever have code that you may need to run on a different operating system, Python is very likely going to just work. The guys behind it have done an amazing job making sure that Python works well on all the major operating systems, which means that when you're writing code that needs to be cross-platform, it's always a good choice. I was speaking to an engineer at a company I won't name a little while ago who are using Python as a file system filter because it's cross-platform. So they've written a cross-platform file system filter that's intercepting file system calls and changing reads and writes, and they've written that in Python because it's cross-platform. And it has powerful libraries. Why rewrite something when you can just get it from elsewhere? Python has one of the best collections of libraries out there. If there's something that you need, it's probably there. But what about Node.js? Why would you use Node.js? Because of its thorough asynchrony and the way that it's been set up, it's really good at dealing with high volume and low latency requests, much like a web server, much like what we want for our web servers. Calling it a glorified proxy is probably a little bit unfair, but on the other hand, that's actually a really important area of application for those of us that already have running code. Web API layering is a way of taking an existing system you have, and maybe it's a crufty old Java app that's 15 years old and spitting out really ugly XML, and you need a nice JSON API with authentication, and you don't want to go back and touch all that old code because it works. Node.js can come in, can be a proxy right in the middle of that, the public part of your API, and suddenly you have a nice modern web API without having to touch your old legacy code. And because the asynchrony is built in, because it's so deeply ingrained in the language, it actually makes Node.js a really good candidate for Internet of Things. Low-power devices need the ability to suspend their hardware when it's not doing anything. And when Node.js is integrated that closely, it knows that it's not doing anything. It can switch into low-power mode far more efficiently than a lot of other languages can. That's enough talk. I have demos. I'm not planning on keeping you here too long, but before I do that, does anyone want to bring up any questions? Okay. Can you use the microphone?
I know this isn't really about the topic of the course, but whatever happened to IronPython?
So IronPython is very happily living out in the community now. So for those who don't know, IronPython was a separate implementation of Python, Python being the language, CPython being the most commonly used implementation of that language. IronPython was an alternative implementation, really good at interfacing with .NET and managed code, made it really transparent, really nice. But it was a project that we found was not as beneficial for what our team was working on at the time. And rather than simply killing it, which is, back in the day, that's what normally would have happened, we passed it on. And so there's people out in the community, there's a community grown up around IronPython who love it, who are supporting it, actively developing it. They are making releases, not incredibly frequently, but they are still going. So IronPython's still alive, it's still going, and we've actually basically completely lifted our hands off it, and it's going fine without our help and without our support right now. Anything else? Okay, so I have 3 demos that I'm going to go through. As I said, any of these could be done in any language of your choice. And the fact that I've chosen a particular language for each one doesn't necessarily mean that's the best choice. It's the choice that I made. So you could do these in different languages if you wanted to. The first we're going to look at is some Azure management. So I have a script that I'm going to add a few bits to and walk you through how it works and what it's doing. We're going to basically automate a process. So let's say my business has some task once a month, maybe once a week. Someone has to go out and spin up a virtual machine, install some software into it, run some process, get the results, and then kill off the machine because we don't want to be charged money for having that there all the time. This is something that's really easy to automate through Azure using a Python script in this case and the Python SDK for Azure and its management APIs. So for this, let's bring up the code. I'm not explicitly going to demo Visual Studio to you guys. I assume you've seen it before. So I'll be implicitly demoing a whole lot of stuff as I go through this. But I don't feel the need to insult your intelligence by saying, oh, look, you can type stuff and it changes color. Or I can hover my mouse over it and get tooltips. So this is the code I have here. One of the things that I have done already, because it's always worth doing before you come in for a live demo, is installed the Azure package. So Python has a few concepts of package management. The one that I'm using here is called a virtual environment, which is project-specific packages. So these get installed just for this project. It's not especially important for this case. And if you want more details, then I'll point you to a video at the end that can help you understand that better. But I've pre-installed the Azure package, and from there, I've imported, and in fact, I'll show you this. Service management, I've imported, there's a whole lot of classes, a whole lot of functions, and by importing star, I'm just getting all of them. There's a bit of boilerplate here, but eventually we're going to end up with a certificate in OpenSSL format, because that's what Python works best with, and the subscription ID for your Azure subscription. These publish settings file has just come off Azure, and the helper function is from our SDK to help you get that all into the right format, so you can do it once and then forget about it, and it'll be fine. You can see the commented out code. That's why I remember what to type, but I am going to type it because that's going to help show off Visual Studio for you. So we work with an instance of the service management service, which is a great name, right? And when I create this, I need to pass in a subscription ID, which I've already got, and the cert file, which I'll get from that cert file constant. And now this has given me an object with a whole lot of commands, and this is where most of these commands come from. So creating virtual machines, managing VM images, deleting images, getting details, listing the services that I have. Basically, anything you can do through the Azure portal, you can do through this SDK. I'm setting up a few constants here for creating the machine. First thing I'm going to create is a hosted service. Because by doing this, this gives my virtual machine somewhere to live. And it's got to live inside a service so that if I want to switch between production staging deployments, I have sort of one banner for them all to live under. Now, all the operations are function calls. And some of these are complicated function calls, which means they have a lot of parameters. Some are upwards of 20, 25 parameters to these function calls. You don't have to specify all of them typically, but in some cases you do. But because this is Python, it has a really neat feature where you can set up a dictionary full of the parameters and the values, and then pass in the dictionary. So I can set up most of my configuration like this, or I could have been reading this from a file. Python has a lot of inbuilt file parsers. There's a config parser for any type files. It has JSON. It has XML. There's packages for YAML. There's packages for anything you can think of. So for this example, I'm using a dictionary of configuration. You could do this any other way. And then setting up most of the config here. I'm not going to bore you by typing this out. We're setting up a Windows machine. We're setting up some endpoints because I'm going to need to hit an HTTP server that's already running on this. And when I was debugging, I wanted to be able to remote desktop into the machine and figure out why it wasn't working. So I had that one there, but we don't really need that now because everything's going to work perfectly. It's a dictionary, so I can add more parameters in later, and these will go into my configuration. And so when I actually create the virtual machine, instead of typing out all the parameters, machine deployment, instead of filling out all these parameters, I can do double star and pass in VM config, which is going to say, take this dictionary, every single key is a name of a parameter, and fill in the value for those parameters. And it's an asynchronous operation. It's mostly a REST API, with some operations take longer than an HTTP request will allow. So there's functionality in here to wait for an operation to complete, which is this wait for operation status. I have some boilerplate code here to wait for things to get started. And in fact, I'll show you that because I'll start running. And now we're in debug mode, and we're debugging this script. So it's going to start spitting out output here. I'll bring it up there. And what this VM image that I'm using actually does, should see some output. So what this VM image I'm using actually does is it has a C compiler pre-installed. So it's not just a plain old empty VM. It has a C compiler, and it has a basic web app running on it. So I can spin up this VM and then say, hey, here's a Python package that includes some C code that I need a compiler if I want to install and use this package. So I do on this machine, but I'm going to install this package on 1,000 machines, and they don't all need a C compiler. So by using this virtual machine, I can spin up a machine with a C compiler, quickly build the package, and then take the result and publish that to all these other machines, so I don't actually need a compiler on each of them. And to do that, I've exposed this basic little web service. So when the virtual machine is created and running, we're going to send a request, just a simple request that says, hey, do this wheel command on the package Flask. And I'm just sending that from Python. It's one line of code just to do a simple GET request. Then I'm going to pop open the browser so we can see some results coming in. And then we're just going to kill off the machine because the longer the machine is running for, the more we get charged. I considered not showing you that bit because everything up to this point has been completely free. And then the virtual machine running is how we make money. But if you kill it really quickly, we don't make as much money off you. So if you want to leave it running, feel free. But you probably want to kill it off as quickly as you can. OK, so Windows VM, so the time between starting the machine and it actually running and being able to respond to a web request, may take a little while. And I got through my explanation a little bit quicker than I'd hoped. So that is still going. But it is working, which is a positive sign anytime you're doing a demo. So other things that you may use this sort of process for. This is the sort of thing where maybe you have a task that once a month you need to grab a huge amount of data out of a data warehouse somewhere and process it, and you need a really big, beefy machine. We have virtual machines on Azure that have, 400 gigabytes of RAM, and will give you 5 terabytes of SSD. And if you're working with a huge data set, that's the sort of machine that this can actually help you with. But it's not a machine you want to keep running all the time. Unless you really want to give us all your money, in which case feel free to keep it running all the time. But you don't want to keep that machine running all the time. You want to spin it up and spend 5 minutes doing your processing, and then shut it down as quickly as possible. This is ideal for that, because when this machine starts up, it's going to run whatever startup scripts it has. You can automate the entire process. Now, the site's ready, and we've hit the breakpoint here. So I can see the URL where the machine is at. We're joining that, and we're going to do a request. So that's nice and quick to trigger the process. And now I'll spin up the web browser, which is simply showing me a list of how much of Flask we've built so far. So as I keep hitting refresh, we should start seeing packages appearing here. Here we go. So this has downloaded some packages off the Python package index. It's compiling them and putting them into a redistributable format called a wheel. This markup safe is the one of interest because this has a compiled C module in it. You may not be able to see that on the screen, but that file I've highlighted is a compiled module that we just built with the compiler on that machine. And now it's in a zip file, so I can just copy it onto the machines that need it, and none of them need a compiler. And back here, we're just going to delete the service. The delete deployment, wait for the operation, and then clean up the hosted service. And then we'll be done. That virtual machine that we just created, ran some task, and now destroyed, probably 10, 20 cents worth of time. And this is automated, so you haven't even had to pay someone to sit here and do this. So when you've got operations that need a separate machine or need higher processing requirements, this is a great way to automate being able to run that entire process. Does anyone want to throw out any questions about that one? Or suggest anything else for me to try before I move on? OK. So the next demo is a web API wrapper. As I mentioned, that's calling Node.js a glorified proxy is a little unfair, but still completely accurate at the same time. And so we're going to do that here. I have an old, crafty API that's actually written in Python because it was quick. And it's returning big, chunky XML data from some internal system that I've got that I don't really want to go in and mess about with the code at this point. But I do want to expose it as JSON. I do want to expose it in a way that other people can get to it and use it. And the other thing that I really want to do is fix up those annoying 2-digit years in the dates and make it a nice portable date format that people outside of the US can understand because they got the month and the day the right way around. Did that sound bitter? That wasn't meant to sound bitter. OK. So this is the old crafty API. It's Python code. It's just for the sake of the demo. So I'll just start this running. And just for the sake of demonstrating, I've got a basic little thing here that's just going to show you some of the data that's in there. This is what it's sending back. This is the API that I'm telling my mobile developers, you have to use this. You have to write a web page and some JavaScript to figure this out and display all of that information there. See, and this date, I mean, is that 3rd of July? No? Exactly. So I'm going to go through this, and I have a cloud service here. All of the support that's in Visual Studio already is going to work for Python and Node because we've made it work. We've extended on top of the Visual Studio support, so if you're not sure how to do a web app with Python or Node, you actually just make a web project, and then in exactly the same way as you would for C#, you right-click the project and say publish. The same thing here, we have a cloud service, so I want a new web role in this case. So I'm going to add a new web role project and go to Node.js and just make a web role. This will give me a basic Node application complete with a breakpoint, a basic Node application that I can start coding in to make a web app that's going to forward incoming requests onto that backend server and then reprocess the data on the way out. To help me out here, I might have pre-written some of these, and I'm going to do some copy-paste. So every time the Notepad window pops up, just close your eyes. Starting with some requires. Node.js has a whole lot of packages as well, and these are absolutely essential if you're going to be working with it. And the require statement is how you bring those in. We will actually give you suggestions when you start requiring stuff. Just like in Python, when you type import, we'll display all the packages you can import. We'll give you the full list of everything that's there for you to use. And the first one of these I'm going to use is the URL package because I need to do some parsing on the request. This function taking rec and res is going to handle every single incoming request to this process. So I need to be able to route these around. Now, there's 100 different ways you can do URL routing in Node.js. I'm doing it fairly simply, just using the route package because I don't have that many to deal with. But the first thing I'm going to do is pull the path name out of the URL. So URL's parse function, and then rec.url, and that should give me a path name back. That is going to be the name of the path. So everything after the, in my case, localhost and port, everything after the host is going to be in the path name. I'm going to cheat and grab some code, because what we do here is we call through into these routes. So the routing module, or the path match module, more specifically, lets me define basically some comparisons, effectively a regex, that also does some parameter substitution. And so when I say, let's get the parameters from user summary from path name, it's going to match user and then put ID into a property, which you can see right here. We are then going to take that property, pass it to a function that I haven't written yet, that is going to get the user info out of that, extract it, and give us back this data object, which we're then going to convert to JSON and return to the user. So this is the core functionality of the proxy. We're going to get the data for a certain ID, and we're going to reprocess it into something that is JavaScripty, convert it to JSON, and res.end will send it back as the response to the request. This function that I need is going to be getUserInfo, and we'll take an ID. And because it's Node.js, we are thoroughly asynchronous. So with my function, I get the input parameter, which is ID, and I also get a callback function, which I've called getInfo, because we're going to call it when I've got the info. I am sure there is a good style name for that, but I don't actually know what it is for this case. GotInfo seems to work fine. But I move that up. And the first thing we're going to do is go straight to an HTTP GET. So GET, OK, apparently callback's a good name for it, because that's what HTTP uses. We're going to do a GET. And inside this GET, I'm going to take more code from here. We're going to pass in this case, a really poorly hard-coded reference to the old API. But this may be exactly what you do. If your old API is an old program you don't want to touch, but the system it's running on is fine, maybe you want to deploy this proxy on the same machine, and then you are just forwarding requests to localhost, and you're avoiding a lot of network bandwidth, and so you don't actually have any sort of slowdown by injecting a node layer in front of your old API. And again, this is asynchronous. This function with the response is going to be called when the request is completed. The first thing we need to check is whether it failed. Because if the status code is not equal to 200, then we want to call the callback immediately. And you can see that this callback function is expecting to get the status, and it's expecting to get any data that we have. In this case, we only have the status because it's a failure, so we'll just pass that in, and then we'll get out of here. And now we know that at this point, our request has succeeded. We have useful information from the old service that we can start transforming into JSON. This code took me a while to get right, so I am definitely not typing it on stage. Who here likes XPath? I didn't think so. But it's actually not a bad choice for doing this. So what I've done is I've grabbed the XML DOM package and the XPath package. Actually, the XML DOM one might be standard if I think about it. No. So I've grabbed these two packages to help me parse the XML, because I really don't want to be doing this client-side. I don't want to have to be relying on XML parsing client-side if at all possible. And so I'm doing that here on the server. There's a bit of boilerplate code, effectively, for getting all of the data out of the request. It's asynchronous, so you need callbacks that will keep repeatedly being called until everything's complete. And then I simply parse the document from the string, from the response, and just define an object. And so this user object that I've created has all of these properties. It has a balance, it has a history, it has an ID, it has a name. We've recognized all of these properties on the object from this definition. And we should, in fact, even know that they're strings because we've called toString on everything. And this gives us a JavaScript object that we then pass to .info. So then the result of .info, which should be here, is going to take that and stringify that, make it into JSON, and return it. And that, assuming I've done everything right, should be enough. And we can start running our Node.js layer. Oh, no, it's not enough. It's not enough because I haven't installed any packages yet. So Node.js has a convention of a packages.json file, which includes a list of all the dependencies that your package needs. The nice thing about these is that when you go to publish a package onto NPM, which is the package repository, you need to provide this file. When you're building a project, you need to have this file. So if you've worked on any Node.js code at all, you have something that can be published, which means there's a lot of code that's been published, and you have a lot of choices when it comes to doing basically anything in Node.js. Now, if you were watching, you'll notice that after I added those dependency lines, we suddenly showed up with a few missing dependencies here. So I can simply install missing NPM packages to go off and get all of those. And now they're installed. And now when I start running the code, we're running successfully, and I've jumped over to our new API page, for which I already have URLs here. So this is the old XML that we don't ever want to see again. And in just a small amount of Node code, we suddenly have JSON that can be easily parsed on the client. It can be parsed on any browser, any mobile device, tablet, PC, gaming console. Anything that can render a web page can now parse this and display that information. What haven't I done? I haven't fixed the dates. So let's have a go at that. The point where we're handling the date is right here. We have an XPath select and just getting the date from the user and converting it to a string. I know I'm going to write a function called fixedDate, so I'll just call it that. And now I have a function fixedDate. And we already recognize that S is a string. So I've only just written the function, no type definitions. We've flowed the information through from the call site down below. So we can tell you that this S parameter has all of these members on it because we know it's a string. Little bit of basic JavaScript code. We'll split it up. We'll add on the 20 to the start of the year, and then we'll reformat it into a date object, which when we convert to JSON is going to look far more readable and be far more portable. And just for fun, let's set some breakpoints and actually step through some of it this time and see what we get. So again, a couple of breakpoints, just hit F5, and we've hit the first request. It's come in. I can hover over the URL and see that the request is coming through, and it's just for the slash, which is not going to meet that. It's not going to match user summary. It matches home, which is where we get the welcome to our API from. Now this time when I hop over here, now we've come back in, and the URL in this case is user 101. After we parse that into params, you can see we have the ID here, which is 101, which is the user we're trying to get. Sorry for that being so small. And now we've fallen out because the call that we've made is asynchronous. So the next step doesn't happen until it's ready for it to happen. And now I've skipped ahead a bit, and so we're into the point after the request to the backend API has come through, and we're about to parse the output. So here's the output, which is the XML. Now let me bring that up in the XML visualizer to show that if you want to look at XML inside Visual Studio, we can format that nicely for you. And we can, in fact, do that for a few other formats as well, none of which make sense on an XML string. But we have an HTML and a JSON visualizer, as well as just a plain text visualizer, which will show you the current state of your program in a way that makes sense and is helpful for you. And this time, when I step in, we've ended up inside the XPath module, which looks like a scary place to be, so let's not do that. And now we're in fixed date. And inside here, we can see the strings, 4/20/15. We've split it. We have an array. We've adjusted the year, and so now the year says 2015, and we can pass in two of the elements for parts. And we're fixing a few dates. And now we've got the info. So now we're going to JSON stringify the data, and hopefully at some point we get, here's the data. So now I have JSON, so I can preview this with a JSON visualizer. And this one's even more advanced. We've got a nice tree view. We can actually search through to find properties that we want to look at inside the JSON, all inside Visual Studio while I'm debugging this program. And now when I continue out, we see that the dates have been formatted unambiguously. It's even figured out that it was 7 o'clock in the morning. And we know that this is, in fact, March the 12th and not the 12th and not the 3rd of December. So that's some Node.js fun. Does anyone want to ask anything about that before I move on? Can you do this in Python? Yes, you can. Would I recommend it? Probably not. There's some libraries that will give you high-volume requests or high-frequency requests in Python just as well as Node.js handles them, but they're not baked into the language in the same way. Node.js is ideal for this kind of use, and so it's going to be a good choice. For my final trick, this is more an interesting demo of the Visual Studio support than something you may actually decide to do as a result of having been to this session. I hope that the last two things have inspired you in some interesting ways, that maybe you can automate some of your processes without spending a huge amount of time developing a tool for it, or maybe you can make that old horrible API something that people actually want to use. This one's a little bit just more fun, and something that if you're already using these sorts of things, then you may find this useful. You may find this really appealing, and definitely a lot of people have told us that this is a great value add for the stuff that they're doing. So I have a Python script running on a Linux machine. Why is it running on a Linux machine? Because it has some dependency that won't work on Windows. That's not strictly the case for this demo, but it may be the case. It's absolutely feasible that there's some tool, some program that you need to be running on Linux that cannot be run on Windows, and so you have a script that's doing it. But something is not working properly, and that script is not working very well, and it's a Python script. So your two choices are either go through and add a whole lot of logging to try and figure out what's going on, or you can dive in and try and use one of the regular Python debuggers or use one of the Linux-supported Python debuggers, none of which are as good to use as Visual Studio. So this is the third option, which is let's enable remote debugging on the Linux machine so that we can connect to it from Visual Studio and get all the benefits, all the functionality of VS without having to move the code somehow to our local machine. So I'm going to start on my remote machine just to show you what's going on. Here's my script. What it's actually doing is it's taking some of my holiday photos and it's creating thumbnails for them. So I put a whole lot of photos up in some Azure storage blobs, and it's downloading the photo. It's running it through an image processing library, which is my only works on Linux example for today. It actually works fine on Windows. But for this demo, it's running on Linux, and it's creating thumbnails for them. You can see it's printing out a whole lot of errors when I cancel it, but it's printing out sets of URLs. So the first URL it's printing out is just to remind me which one it's gotten. And there's my image. This is from my last trip back home to Melbourne. That's a tram. In fact, you probably know about those because they have kind of things like them here, don't they, in San Francisco? That's a Melbourne tram. Very nice way of getting around. And here is the thumbnail that we've generated for that. And you can see the difference is we've actually put it in a different container with the same name. So the steps that this script have gone through, and in fact, if I bring up the code, then I can show you. Just like before, we created, so from the Azure library, we imported the service management service before. This time we're using the blob service because we're dealing with blobs in Azure storage. And we're listing them, and here are our two container definitions. Bit of code to just create those, but then the meat of it. We're going to this container, and we're listing all the blobs that are there. This is giving us details about everything that's already in that container, which in this case is all of my holiday photos. All of the holiday photos I wouldn't be worried to have appear on stage at build. I'll be clear. And then we're doing a get blob to bytes. That's going to go off and download that image and just load it into memory. So now we have a JPEG in memory in our Python script. And this image.open is the library. This library is called PIL, P-I-L, Python Image Library. If you want to install it, you actually install Pillow these days. There was a dispute about compatibility and a fork at some point, and these days Pillow is the one that works. But this is just a really nice, simple image processing library for Python. And so we'll open that from the in-memory file. We'll grab the size of it. We're going to crop the image into a square. We're going to run edge enhancement because I thought that might be a good idea. Looking at the thumbnails, it isn't, but it might have been. And I am guilty of not updating my comments because we're going to resize to 150 by 150, which is our thumbnail. Finally, we put the data back into a bytes.io, which is an in-memory buffer, a memory stream, in effect, and then put the block blob from that in-memory stream and push that back up to Azure into a different container. And then we print the messages. It's fairly simple. It's actually working completely fine right now. The job it's doing is fine because I couldn't come up with a good bug for it to have, but we're going to go ahead and debug it anyway. So a couple of things we need to do to enable debugging. First, we need to import and install PTVSD, Python Tools for Visual Studio Debugger. This is a module that I don't have installed locally, but I don't need it on this machine because it's only got to be running on the remote machine. This will let me set up a socket connection so that I can connect into the running process. There's a whole lot of parameters you can specify here. The first one I've specified is the secret, which is a password. So if you've been paying attention, you could now be attaching to, well, you can't yet. After I publish this change, you could be attaching to my process before I get there. Please don't do that. That's going to spoil the demo. But you could be because you've now seen the secret, and that's the only thing keeping you out. And then we're going to wait for an attach. You don't have to do this, but this is convenient if you're planning to debug from the start of the code. It's just going to hold up until you've actually attached the debugger. Now to publish this, I'll open a command prompt. This is a crazy command, so I wrote it into a batch file. And that's just uploaded using PSCP. So I've just transferred the file over SSH, and now it's up on the machine. If I pull up Nano demo here, you can see that we've now got this code has been updated. The next thing I need to do is actually install PTVSD because I don't have it on this machine yet. Pip is the package manager for Python, so pip install is going to install the package. --pre is going to install pre-release versions, which I need because I'm running Python 2.2 RC. And so it needs a slightly newer version than you'd normally install if you didn't put the --pre, because you'd get the one for Python Tools 2.1. So this is going to go off and install the package. And once this is done, I can just start running the script again, and we'll be good to attach and have a look. And this time you'll see it's not doing anything. It's waiting for me to attach. Come back to Visual Studio, and under Debug, I can attach to process. Python remote debugging is the transport we want to use here. And there's a bit of an explanation on how to do it. We're connecting over TCP. Machine is secret. Build demo VM3. I could have assigned a different port, but I haven't. And in fact, I should mention this because I'm not actually prepared to show right now. When you set this up, you need to enable the endpoint if you're on an Azure virtual machine, or in fact, most cloud providers. They're not going to be opening this port for public access. So if you haven't opened that port for public access into your virtual machine for Azure that's creating an endpoint, then you're not going to be able to connect. But assuming everything's OK, when you hit Enter in this box, you'll see a list of the running Python processes on that machine. And it's telling me it's CPython 335, Linux 64-bit. And I'm going to hit Attach, and now we're running. I can jump back over here, and oh, it's taking me back because we've hit a breakpoint. So while I'm broken here, I can hover over any variable I want and see all the details just like I would if it was running locally. I can step over using F10. I can see, I'm in fact not going to look at the data for that. I can inspect this image. I can see from the type it's a JPEG image file. I can see all the information that I couldn't have seen before without the package installed. But now because I'm live debugging on a remote machine, it's sending back all the information I'm asking for to see what's going on in my code here. If I hit F5, we'll spin back around the loop. You can see that it got the blob. It did the first one. And in fact, it's also displaying the output here. So everything it prints to the screen, it's going to display right in Visual Studio. There's no need to be switching back and forth to the original process. Now, as I step through, this is doing image processing, and there's a few steps involved. So maybe I want to look at the image at some various points along the way. I've just performed the crop. So now IM is cropped. But there's no actual way to look at the image until we get to this code that's going to save it. So what I'm going to do with this code, instead of waiting, is I'm going to copy it and open what we call the Debug Interactive window. So under Debug, Windows, Python Debug Interactive. And this is a Python shell. And I need to unindent. This is a Python shell where I can write arbitrary Python code, such as, let's save this data to a bytes.io, and then put it into a blob. And so now that's done. And just like below, I can get the blob, I can make the blob URL, the target container, same name, and this will show me this is where it's gone ahead and put the partially processed photo. If I open that up, we'll see it's a nice big photo because that's what it started at, but it's been cropped. If I come back to this script and continue on, so let's step over the filter. Now we've filtered the image. So I can come back up here, rerun this bit of code, which is going to take the image now, live, put it back up onto blob storage under the same name. And I may have just messed that up by hitting the wrong refresh button. And I think that's been enhanced. It's a little hard to tell. But we've come back around, and we should have the thumb. Just let me do this properly. No, it finished the whole process. So let's try that one again with the next image. So we'll crop, we'll run the filter, and now we're up to photo 15. And so we've put this into thumbs for photo 15, which will be the edge enhanced version. It's also the rotated sideways version. That's actually a staircase. Resize step, and now we can run the same code again. And when I hit refresh, it's been resized. So we're actually interfering with the program. We're executing arbitrary code on the remote machine partway through a program running. This is a great way to be able to figure out what's wrong with code without actually having to sit on the Linux box itself or SSH into it and work through everything step by step. Does anyone have any questions about that before I move on?
So this is running in the same environment, which is why you can just pick up blocks and do stuff with it?
So the question is effectively, is this running in the same environment? So that's why I can just pick up blobs and do stuff? No, it's not. This code is all running on a machine over in Azure land somewhere. I'm not exactly sure where. The machine is builddemo.vm3.cloudapp.net. If you want to DOS it and bring it down, you're welcome to do that now because I'm done. This is running off in a data center somewhere. And these URLs are real URLs. You can go to one of these and check out the photos if you want. These are open on the public internet, and I'm actually pushing public photos onto Azure storage as part of this demo. So this is not faked. This one is a real demo. OK, here are a couple of links. Get your phones out and take a photo, but they're not that hard to forget. Our Python tools for Visual Studio and Node.js tools for Visual Studio. These are where you can get to the overview pages, and those will lead you through the other things you need to download and install, as well as get you into some videos and overviews of what these are used for and what we're actually doing with them at Microsoft. The last link there, if you're not sick of hearing me talk already, is a video series that we recently did. It's an introductory, so from absolute first principles, getting set up with Visual Studio, Python tools, Python, and then using the editor, the debugger, all the way through to some really advanced remote debugging, like I just showed, mixed mode C and Python debugging, which is really cool. We have a whole video series of that. That's at that link. Your world has changed. Everything's different. You're doing different things. Different things require different tools. You can't use the one tool, no matter how great it is, for every task you have to do. You need a toolbox. Node.js and Python are powerful, flexible additions to this toolbox. 2 slight asides. Be prepared for cross-platform. This is becoming so much more important these days. You are doing yourself a disservice if you're not thinking about how you may be able to be working with other platforms. If you're entirely locked in on Windows, sooner or later that's going to come and bite you. Node.js and Python are already cross-platform. If your code is in those languages, it will work on other platforms. It's a free way to get that benefit without having to work too hard. And finally, this is something you'll be hearing a lot at Build. Consider embracing open source. It's been hard, but Microsoft has been getting there. It's taken time, but we've been getting there. We're now interacting with open source in positive ways. We're directly contributing to a huge amount of projects. We have a huge number of developers actively working with open source projects and open source communities, and it's so worthwhile. These days, open source software is where the knowledge of software engineering is kept. It's not journals, it's not university courses, it's in the software that's out there for everyone to see. So please, be part of that. Use it. Add to it. Build on top of it. contribute back to it, support it, and embrace it. Does anyone have any final questions? Yeah. You will be able to find me for the rest of the evening after I've eaten at the languages booth on the 3rd floor. So if you want to come and chat some more, I'll be there. Thanks for coming.